Hello everyone. Today I will present a comprehensive approach to plant disease detection using deep learning. So let me first introduce myself. I am Mohammed Djawed, currently in the third year of a PhD in automation and industrial computing, focusing on visual robotic control for large-scale agriculture. And this is my supervisor, Hussein Shabi. He is a teacher and researcher in the Department of Automation at Jalal University, Sidi Bel Abbas, Algeria. So, our abstract. This presentation presents a deep learning approach for detecting plant diseases using convolutional neural networks to analyze leaf images. The methodology concludes image processing and the detailed CNN architecture, achieving 99.73% accuracy in disease classification. The research underscored the importance of timely disease detection for agricultural productivity and economic stability. This work contributes to agricultural technology and offers insights for leveraging deep learning in real-world scenarios. So, I will start with explaining the structure of this presentation. We will start with an introduction, then move to the methodology, discuss the result, and finally end with the conclusion. Introduction. Plant diseases are a big problem for farmers because they can reduce crop production and affect food security. Detecting these diseases early is very important because it helps manage the problem and reduce crop losses. Traditional ways of detecting plant diseases are slow and often include human errors. However, deep learning and computer vision now offer new ways to automate the process and make it more accurate. Disease detection methodology by deep learning. Our study we used convolutional neural networks to analyze images of plant leaves and classify them based on their disease. Deep learning is a type of machine learning that uses neural network with machine learning which requires manual feature selection. Deep learning automatically extracts features and is better suited for tasks like image recognition. Our process starts with getting a database of plant leaf. We removed the wait a minute. We removed the background from each image to make them cleaner. Then we divided the dataset into 80% for training the model and 20% for testing. Our dataset contained 38 classes including different diseases and healthy leaves, such as apple, potato, tomato, and strawberry diseases, and etc. The images are well distributed to ensure the model learns effectively. So, to build the model, we use K function in deep learning. This convolution is used to extract features from images by applying filters that detect edges, patterns, and textures. Max pooling. This reduces the size of features maps, keeping only the most important information. Let me show you. So, like the most important information while reducing computational complexity. We have rectifier linear unit. This activation function introduced nonlinearity to the model, helping it learn complex patterns. The sigmoid. This function is often used for binary classification, as it outputs values between 0 and 1, which can be interpreted as probabilities. We have the softmax. For multi-class classification, it converts the output into probabilities across all classes, allowing the model to make prediction. And finally, we have the hyperbolic tangent. That is another function that outputs values between 1 and -1, helping the model handle data more effectively on certain cases. These functions work together to ensure that the model can accurately detect and classify plant diseases. So, the results. Here you can see some simple images from each class in our database, which with the class name displayed below the images. So here are the graph of the evolution of training and validation loss over epochs. Like you can see, we used 5 epochs and we achieved a loss of nearby 0%, as you can see here. And for the next graph, we have the evolution of validation accuracy over epochs. And as you can see, we achieved an accuracy of 99.73%, nearby 100%, which is very perfect. So these are 2 examples for our testing for the model, and as you can see here, the, uh, the predictions of these 2 images are exactly the same. With the red color means that these pixels are used to have a good prediction. So when we compared our work to other studies, we achieved an accuracy of 99.73%, which is higher than recent work in the same field. These results show the method is highly effective in detecting plant diseases. So we pass to the conclusion and future work. So this work shows the steps to build to to build a deep learning system for detecting plant disease. We improved the dataset by pre-processing the images and designed a convolutional neural network to identify disease features. Our model achieved a very high accuracy, better than similar studies. In future, we plan to apply this system in mobile devices, or directly in agricultural zones for real-time detection of plant diseases. So, thank you for your attention.